Ah! Stop attacking me. My mic is, apparently has decided that it is not going to stay still today. Come on. Alright. So let's see whether or not Twitch says we're live. Oh, it says we're live. Hurrah! Let's go tell Twitter that we're alive. I know that that is a high priority for everybody. Now, streaming, game dev, gonna try to make piloting snappy. We'll pop on over to here and try and post it again. Boom. And then we'll head over here. I should probably just open those in different tabs when I start, but I didn't. All right, so that's all working fine. So in the current version of this game, things are starting to very slowly come together, but the flight isn't quite as nice as I'd like it to be. There's a feel that I'm going for here, and it's a little hard to explain it just because, you know, it's a feel, not something concrete. But basically, I want to have this kind of smooth motion, right? So that part feels really right. That part feels exactly like I want it to feel. But I've got some problems with what happens when things go awry. So if I were to, for example, bounce off of a wall or something, it just doesn't feel very good to try and figure out how to move or what to do here. In addition, it can feel quite hard to get a good stop going. So if I wanted to brake here, I can set it into reverse, but it's not going to reverse very hard, and I'm going to end up bonking the walls. Now, in a real spaceship, that's correct. Your retrojets are not going to be very good at slowing you down that fast, but I want this to feel a little bit more arcadey. So basically what I would like to do is I would like it to feel like it has weight when you're moving forward, but when you're trying to stop or are largely stopped, I want it to feel really nimble. Pink Air says, hey there. B. Wheatley says, is this still the spacey connection stuff and not the Galactic Line? Well, I have to finish this before I can do the Galactic Line stuff, since the Galactic Line is essentially all of the same content plus another 400 hours of people. And the reason that the reason that I stopped doing the Galactic Line is that 400 hours of people. I'm not really good enough to do that with any kind of speed. So right now I'm trying to work on something that uses most of the same content so that I can work on the Galactic Line in a better way once I have enough content to make it interesting for longer. Yep, that's all. So right now I'm discussing trying to make this fly gracefully, and I like this part well enough, but when we're stopped or trying to stop, it gets to be real grumpy. And part of that is the camera. It's a little bit hard to see what's going on with the camera. For example, right now you can't really tell exactly where we're going without that without that gold hex ball that glows on the walls, that thing there. And that's because you can't really tell which direction the ring is pointed, because it's just a ring. It's not pointed straight out of the camera. It's pointed kind of slightly upwards, and that makes it a little bit difficult to figure out precisely where we're aiming. It's also going to be a problem with the camera when we bump into something and the camera is halfway inside the wall, so we've got to fix that as well. But aside from the camera, there's also just the matter of it not being very responsive in general. It just doesn't really feel very good to try and get this to move around when we're in a tight space. There's just something bad about it. Partly it's the slowness of these engines. You can see how slow that strafing is. It's pretty slow. So what we're going to try and do today is work on the strafing issues and the reversing issues. We're going to try to change how our fundamental acceleration and deceleration calculations work to give us a snappier performance. This isn't just a matter of increasing the engine's strength. It's a matter of trying to get it to feel right regardless of the strength of the engines. So if we take a look at the ship, we pop into our ship control, which is, I believe, here in the cockpit. Ship control system. This has a lot of variables attached to it. And basically what we would like to do is have those variables be a lot cleaner for our purposes. You can see that we've got this set up where there's a heading, an intended heading, a current heading, a forward velocity percent, all of this stuff, right? And that actually goes in and finds all of the engines that could conceivably be pointed the right way, and it fires them, and it does all this stuff. I think that that might be too much physics. So this game, I have some physics in it. I'm not actually sure how much physics I will be retaining, but I do know that I don't really care about the physics of a maneuvering jet. What I would prefer to have is, a feel good to pilot. And for that, instead of having our maneuvering jets only actually maneuver you while they're firing, I would like them to maneuver you just immediately regardless. So basically, I can go into the maneuvering jets and have them respond much more snappily just by ignoring whether or not they're actually firing and pretending they are. We'll leave the all of the calculations in there because they produce a visual that should look pretty nice. So if we go into our maneuvering jets and just pop open the jet system, which I think is inside this. Yeah, there it is. What we have is a situation where we call the controller here. And what we do is we only get here if we're doing a maneuvering update. Is there any returning or braking? Nope. So what we have here is this, which attempts to find the alignment and the thrust vector. And what we're going to do is we're just going to go ahead and return max thrust and ignore alignment. That will give us a much, much stronger response when we're strafing, on orders of magnitude stronger. Or not. That's interesting. It just doesn't work at all now. Well, Oh, is this because the thrust vector is actually being taken into account? Let's go and take a look at this strafe vector here. If we take a look up here at the strafe vector, this actually does determine whether or not we are going to be strafing in the direction we would like. So if we wanted to do this, we're going to have to replace the strafe vector with our fundamental strafe intention, and that's going to be intended strafe, I believe. Here it is. Gets the intended strafe, gets the current amount of strafe, gets the strafe change we're looking for. Here it is. Strafe. Okay. So we'll go ahead and just pass this a strafe instead. The only question is whether or not that's going to be inverted. We will find out very soon here. Yep, it's inverted. So we're going to go ahead and uninvert that. But we're also obviously going to have to moderate it rather considerably. We're just kind of feeling it out at this point. There's a lot of things here that I'm not so sure of. Yeah, okay, we don't have to moderate it. That moderating it out was because we had a negative value and it went out of control. So we'll go ahead and normalize this. That way we won't have a ridiculous, massive super strafe if we are sliding. Normalized. There we go. Hmm. We are strafing, but it is incredibly slow. That's interesting. It shouldn't be anywhere near that slow. Because the strafe quantity should be the amount of thrust just straight out. And the amount of thrust should be the max thrust from every single one of these. And the max thrust should be quite high. Idiot. I changed a minus equals to a minus, or to an equals, rather than a plus equals. That was the issue. Let's try it one more time. Alright, that's snappier. That's more like what I had in mind. So with this, the strafing becomes substantially more impressive. So for example, we can try and get through this right-hand side using nothing but strafing. Oh, nope, we didn't make it. Close call, though. Now, this is a much snappier steering system. Just snappy enough, I think, to make it feel better. Now, the real question is, if we crash this and then try to maneuver our way out, how does it feel? So if we were to bonk and we could just strafe our way through, yeah, that's not too bad. Okay. Another thing I'm going to do is that when we collide with something and stop, I'm actually going to cut our thrust from max thrust down to a small fraction, because accelerating out at max thrust seems like it's a terrible idea. So in here we have a couple of elements. Here in the fixed update we call align. What we're going to want to do is we're going to want to store the last vector and then get the difference between the current speed and that speed. So protected vector 3 last frame velocity. We could also try and get information from the rigid body about whether or not it had collided. I'm not actually sure whether or not the rigid body will tell us that. Collision detection mode. No, that's not it. Yeah, I don't believe that there is a callback for rigid body has had a physics event. So we're going to have to manually track it. So if strafe vector, if last frame velocity minus ship.rigidbody.velocity.magnitude actually, why don't we do this a different way? If last frame velocity.magnitude is greater than ship rigid velocity.magnitude times 2. Times 2? How about plus 5? We've stopped. Pink Air says perhaps increase the thrust when close to a surface, and it'll feel like we're pushing off the surface. That's not a bad idea. I'm not sure that it's going to be necessary, but it's probably a good idea. I'll go ahead and try that in a minute once I've done this physics correction. So if throttle is greater than 0.3, then throttle equals 0.3 F. And either way, we're going to want to set this boom. That way we will now know. So let's just go ahead and check this out. Because a big part of this is when you slam into something with your nose, you'll keep trying to accelerate in a forward vector, and that means that you're pushing your nose into the dirt. So with this, you should at least stop slamming yourself into the dirt. Yeah, it works fine. All right, so now let's go ahead and try that pushing off of something nearby technique. To do that, we're going to have to raycast, and I guess we're going to want to raycast from the thrusters. So we'll go ahead and create a new function for doing a raycast from a thruster. Public bool, public bool is something nearby, is something in the way, is something can push off something. There we are. Later on, we'll also have one that checks the ship and sees whether or not we actually have a free thrust out of the ship's field of influence, or whether or not we're burning pieces of our ship, right? So with this, what we're going to want to do is do a raycast. So ray equals new ray, and it's going to be our transform.position and the thrust vector. I think, yeah, that should be it. Component.center, my bad. Component.center, thrust vector. And then what we're going to want to do is raycast hit. If physics, that's not how you spell physics. If physics.raycast ray out hit, and then a distance like, say, sorry, I'm trying to remember which direction. Yeah, there we are. Like, say, we'll go ahead and call it 10. Yeah, that's fine. If hit.transform.contains, no, is child of ship. Okay, so we need, in order to do this, we need to understand our own ship control. We don't have an easy way to get the controllers, the ship. Can I say controller.ship? Yeah, there we are. Controller.ship.transform. Debug.log warning. Engine name seems to be burning itself, burning the ship. Return true, otherwise return false. So with that in mind, what we can do up here is we can make this max, we can multiply this max thrust if we are close enough to push off of something. So if can push off something, then else this. Yeah, come on, Craig, get your act together. Believe it or not, I've been programming all morning. The problem is I've been programming in a different language. No, wrong one. There we are. So that should give us a little bit of a boost. Pink Hair says, blasting chunks off your ship has a lot of potential for fun, especially when enterprising players use it to create multi-stage vehicles. Yeah, there's going to be, I mean, I've already built the physics into this system. There's a much better physics system in this ship than in any other game I'm aware of, but I haven't actually hooked it up, and I'm still in the process of figuring out whether it's going to be fun or how to make it fun. So there's going to be a lot of things that we can do there. One of the coolest things about it is that it can do center of mass changes really, really easily. So if you have like deployable wings and stuff like that, there's not going to be any issues with trying to figure out what's going on. There won't be any hinge vibrations or any of that stuff that you get in Space Engineers. So let's go ahead and run into something and then see whether or not our push-off works. Bonk. So with this, now if we hit up, oh yeah, that's definitely pushing off substantially better. And I don't see, oh wait, it's not, yeah, that should work. I don't see any issues where it is saying that it's burning off the ship. So it looks like our collision detection is working out pretty well. Let's try it at some high speeds. Pretty good. That feels pretty good. Now, this is a lot like, sort of like Sonic the Hedgehog in some ways, in that if you're moving fast, it feels pretty good. But the instant you stop, it's trash. It's just awful. But this is a game where I want players to move at the speed they feel they should be moving. And that might be fairly slow. So I need it to feel good when you're moving slow, and I also need it to feel good when you impact on something. I've actually done a lot to fix that already by reducing your forward thrust and giving you a better set of maneuvering jets. But when we are decelerating like this, we decelerate really pretty slowly. I guess it's not that bad. I might have to think about whether or not that's good enough. Bonk. Away we go. I'll have to add in a sound effect when your throttle changes. Maybe it'll be a sound effect of me saying bonk. Because otherwise you won't realize that your throttle changed. And I'm still a little bit confused as to how well or if this green ball, this yellow ball thing here, whether or not this will actually work for people other than me. Because for me, it feels really, really good. It's like super smooth to figure out where you're going and whether you're going to run into something. But I don't know if that's going to translate to anybody else on the world. I suppose we'll find out when I release a version of this. I'm getting pretty close to a version that is at least vaguely playable, but I still need to set things up so that there is some fun to be had rather than just a couple of random things and a ship that you can fly through. Alright, so now we still have some camera problems, and those are definitely the most pressing issues I have at the moment. So to make these camera problems fix themselves, there are a couple of things we need to work on. One is the nature of forward, because we're not actually flying straight out of the camera, we're flying a little bit upwards. So in order to make that work, in order to look straight ahead, what we would end up having to do is look straight up the tailpipe of the ship, and I don't think that that's any good at all. The whole point of this is I need to be able to see the ship, and in order to be able to see the ship, I need to be able to... where'd it go? Oh, it's way up there. In order to be able to see the ship, I would need to actually be able to see the ship itself and not like just an arbitrary back segment here. So if we hit play, yeah, you can see this is what it would look like if you could see directly where your ship is going. Now there are some graphical tricks I could use to try and make this work out. One is that I could have the POV screw up a little bit. It's possible to shift the frustum away from a centered screen. I can make it so that looking straight ahead actually looks at like the top third of the screen, and I could put a little point there. Another thing I could do is I could move this ring above the ship so that you're piloting the ring, but it's actually offset from the ship. However, in tight situations, that gets a little bit iffy. Because now there's a significant enough delta between you and the ship that it becomes a little difficult to see what's going on. Another thing I have to consider is that the player is probably going to want to just have their own camera controls. So an alternative to all of this nonsense is to set it up with a visual that shows us the direction we're traveling in a much more aggressive way than these rings currently do. So, for example, I could take this piloting ring and I could add in a little cube, like so. Take the box glider away and make it have the same material, which is the adaptive material gold. Yeah, we'll go ahead and copy that. And then paste it here. And we're going to want to drop the same shader in as well. This is running with the velocity material, so we're going to go ahead and replace this with the velocity material. And I think that that should be fine. But we're going to want to actually make it so that it works visually. So for that, we're going to go ahead and reduce the scale, except for on the z-axis, where we're going to increase it rather considerably, like this. And I'm just going to test this out and see whether or not it makes any sense at all as a visual. Pink Hair has said some stuff. Give me a minute to take a look here. So you can see that one of the problems you've got right away is that you can't really see it. The arm of the ship is sort of in the way. I think that maybe fussing with the frustum would work better, but the problem is that I don't know how to do it. So Pink Hair says, perhaps some sort of aligning to surfaces when moving slowly might help with the slow traversals. Could have a picture-in-picture nose camera. That's actually really expensive, unfortunately. But if I was going to do that, there's no reason to have that happen. You could just go into the ship and put the camera in the cockpit. How about a tunnel of concentric rings ahead of the ship? Oh, that's an interesting idea. Let me think about the best way to do that. Well, I have to have a tunnel to do that with, so what we'll do is we'll just duplicate this piloting ring. We'll put it inside here. And we're going to call this the Superman rings. And we will go ahead and set up these Superman rings to be in front of our ship. Now the question is whether or not it's better to go big than small or small than big or whatever. So we're just going to create a couple just to have a couple. And what we're going to want to do is obviously offset them by the velocity of the ship in some way. But for now, let's just go ahead and try it out like this. So you can see how far those are off from forward. Those actually do give us a good indication of where forward is. Yeah, I think that that's probably not a bad idea. But you can just see how bad our idea of forward was until this moment. It's nowhere near the center of the screen. It's way upstairs. Yeah, that's actually not too bad. Now, one of the issues is that these things do fall through items, but I'm actually kind of thinking maybe I like that, because it gives you a feel for exactly how far apart or how far you are from these destinations. I think that we're going to want to change the distances involved here. So I guess they're probably okay now that I'm thinking about it. Yeah, those distances are fine. I even think the sizes are fine. What do you guys think? Do you think that this might make it easier to see where you're going, or do you have other ways that you would prefer to see it displayed? These kinds of Superman rings feel pretty decent. Originally, I was going to have them kind of flop around with the velocity of your ship, but I think having them rock solid is actually more helpful. So maybe I will just leave them as fairly rock solid like this. Yeah, I'm not 100% sold on the visual, but it does seem to feel right. Maybe what I need to do is make it so that the velocity of the ship is actually indicated in a vertical ring like that instead of a horizontal ring. Not sure though. Pink Hair says I'd probably just use color for velocity. Yeah, so there's a couple of things in play here. One is velocity and the other is throttle. So right now, throttle is what gets the color of the horizontal element. The question is whether or not that horizontal set of rings has any meaning now, because I should be able to get the same performance out of a vertical set of rings. Let's go ahead and try it. So the big problem with the vertical set of rings is that the meshes are arranged specifically so that they are not vertical. I did that so that they had a forward on them, right? That's not the right script. That is actually a debug script that I can remove. I don't need it anymore. Boom. This is what I was trying to do. Material, pilot ring, mesh. Here it is. So where is our pilot ring? Here it is. So this is the pilot ring. Boom, as you can see. And that direction, straight up, is what Unity considers to be forward. So when I duplicate this ring and rotate it 90 degrees on the x-axis and move it, or just apply the rotation like this, suddenly it's got two sets of random things attached to it. Let's go ahead and fix this modifier a little. Yeah, so we want the Z modifier, don't we? Yeah. So now this will be up, and we can call this the Superman ring. If you're wondering why it's called the Superman ring, then you've never tried to play Superman 64. But I could call it a Star Fox ring, I guess. So now we've got a better set of rings for our needs. And if I were to change the mesh from the pilot ring to the Superman ring, it becomes a vertical element. It also becomes upside down, so let's just flip it. Boom. Boom, there we are. And we're also going to want to do that on the strafing ring. So say Superman. Now the actual performance here should be exactly the same, but we have a nice sort of offset. One of the issues we have now is that this is aligned with the control element of the ship. We actually need it to be pushed forward rather considerably. That's something I think we'll want to do in code, so let's go ahead and do exactly that. Where is our piloting here? There it is. We have this system where we program it to specifically come back to our location every frame. I think it's under update. Here it is. Ideal strafe pause. So what we're going to want to do is move the ideal strafe pause forward. And we're going to move our ideal strafe pause forward by the ship's forward vector, which would be our forward vector. So we'll go ahead and call that transform.forward times 25. And we'll just see whether or not that feels good. It didn't, oh, it's a strafe. I moved the, sorry, not the ideal strafe pause, the ideal pilot ring pause. Here we are. So I know that here we are. This is it. Vector 3, ideal pilot ring pause. Transform.position plus transform.forward times 25. And then here we'll go ahead and ideal pilot ring pause. And ideal pilot ring pause. Now the strafe ring is inside the pilot ring, so it should just get swept along for the ride. Okay, so now we've got the problem that our camera is actually looking at the pilot ring. So what we end up with is a view that doesn't really include the ship at all. So if we wanted our camera to look at the correct ring, or the correct place, and instead of pointing it at the pilot ring, we could always point it at something else. But the thing I really liked about our camera is the fact that pointing it at the pilot ring offsets the view somewhat. So I think what we're going to need to do is change the nature of the pilot ring. to have another pilot ring element and then have the visuals separate from it. I don't think there's any way around it. So we're going to call this the pilot visual element, the piloting visual element. We're going to drop the piloting rings inside there, like so. And we're going to go back into the cockpit's code, and we're going to change the system so that it has a couple of different values. We've got the pilot ring, we've got the pilot visual element, pilot ring and strafe ring. So the pilot ring and the strafe ring turn in certain situations, but that can actually be done against the pilot visual element. It doesn't need to be against the pilot ring. The reason that we've been using pilot ring and strafe ring so far is just because they've been the same so far. We haven't needed to change anything. But basically, we're going to want to undo everything I just did with this. There we are. And then we're going to want to manually move the pilot ring forward by 25 or so. No. There we are. But the issue here is that right now our cockpit is pointing at the pilot ring visual. So we're going to call this a visual. And we're going to call this the pilot ring. And then down here in the cockpit, we're going to have to reassign the pilot ring to the new pilot ring. And down here, where we have this on strafe changed and on throttle changed, these are pointed to the visual. And the point there is that the visual will go ahead and keep up. We can drop in the other Superman rings and have them all reflect our throttle. Okay, let's see whether this fixes things. No. Why are we still... Oh, because the main camera hasn't been reassigned. Give me a moment. There we are. No, not the cockpit, the pilot ring. Sorry, I'm rearranging the hierarchy here, and that means that there's some times where it gets a little bit screwed up. So, as you can see, it's not really behaving very well. And I think that the reason for that is because it's rotated wrong. I just don't remember. So I think it's got to have the same rotation as the visual did originally. So we're going to drop this in here. I actually don't know how to tell it not to do that. So... Okay, so take this out, and we're going to try and get this pilot ring to behave. Give it the same rotation, which is 270 and negative 180, which is an odd set of rotations. Let's see whether or not this... Okay, so that does work. Now all we need to do is put the visual back inside the pilot ring. There we go. All right, so you can see how all of the rings now reflect your velocity. Oh my gosh, what's this? Do I have a... I have a Superman ring at the back here. Oh, interesting. That's not a very good place for it. Let's go ahead and adjust these Superman rings so that they are all... more forward than that. So if we were to, if the visual here is 25 ahead, then this should be 50 ahead, and this should be 100 ahead, and this should be 200 ahead. Yeah, that's more like it. All right, now we're back to it feeling pretty sharp. For some reason, we are hauling ass, though. We are much, much faster than we were before I made this change. Which is kind of an interesting thing to do. I didn't think... Why would it have changed? There shouldn't be any change to the speed, but it feels so much more responsive going forward. Still feels crappy once you hit something, though. I can't seem to... Well, it's not that the strafing is any less snappy. It's just that the strafing is now such a smaller percentage of the overall speed that it feels less snappy. Oh, the strafing is actually wrong. It's interesting. So you can see that the strafing now actually shows the direction it's trying to go more correctly. But for some reason, it's being interpreted funky. It's not giving us the proper strafe commands, I don't think. This is why you gotta think when you're building stuff, because otherwise it'll just screw up. Yeah, it's not being interpreted correctly. So I think the problem is that our strafe is using a local space. Strafe ring position minus pilot ring dot. Okay, so here's the problem. The strafe ring position minus the pilot ring dot position is the issue here, because the pilot ring dot position is 25 behind us. So instead what we're going to do is we're going to call this strafe ring dot parent. Strafe ring dot parent dot position. There we are. That's the same as the local position, except for it is the local position without any of the parent's modifications or scales or rotations applied. So it's the global local position. And that should work. Don't need you anymore. That might be one too many Superman rings. Okay, let's go ahead and delete the forwardmost Superman ring. And obviously we're going to have to go in and remove that from our event system. Here we go. That feels funky. The offsets feel wrong. I think the pilot ring needs to be moved. The visual needs to be moved forward more. How about 50? Pink Air says to change it to a crosshair. No, I kind of like how it doesn't have a crosshair, because it feels like you're shooting down a tube and not towards a brick wall. But I mean, there are lots of more there's lots more polish I'm going to have to do in the long run. All right, so that did repair everything. The thing that we were seeing before is that the ship was attempting to strafe forward continuously while also accelerating with its main engines. So we were getting all of the strafing engines as well as the main engines, and that was why we had that extra speed. It was also why we couldn't strafe worth a damn. No! Yup. This feels pretty good. All right, so there's a couple more things I want to try. One of the things I want to try is taking this arm and moving it to the side of the ship. Up, up, up. And then if I duplicate this and give us another arm on the other side. Now we're a boxer. Now the reason I want to do this is because they were kind of in the way, and I want to get a feel for how this feels with all sorts of visuals. I've got some jitter, and I'm not sure exactly what the cause is. I'll have to think about that. Bonk. So here's the fun part. If I go through this tunnel here, Well, the arms each grab for their own preferred target. Yeah, they do. They're not very good at it yet, though. So you can see that vibration. I don't know what's causing that. I think it's an actual vibration. I don't think it's the Oh. When we go into reverse, it puts the Superman rings behind us. Which is technically correct. I just don't know whether or not this vibration is the ship vibrating or the camera vibrating. So I'm going to look up here, frame by frame, and see whether or not it is the ship or the camera. So as you can see, we've got 17.03, 5.25, and 607.3. They seem to all be moving in the same direction. Yeah, I don't see anything vibrating here. They all seem to be progressing at roughly the same pace per frame. So it might be the pilot ring. Yeah, it's the pilot ring. You can see how X is vibrating. 17.159, 17.087, 17.128, 17.055, 17.09. So there's some vibration happening in the pilot ring. Well, we're setting the pilot ring's position ourselves. And it's based on the velocity of the ship. So what I'm thinking is that the pilot ring's location is vibrating due to changes in the velocity of the ship. But that's kind of odd. Either way, what we're going to do is we're going to lerp the hell out of the pilot ring, and that should work. So there we go. And then we'll just say pilot ring.transform.position equals vector3.lerp. Pilot ring.transform.position. Ideal pilot ring position. And time.delta times some value. 10 is probably fine. Just because that vibration is really obnoxious. I don't think this will actually help very much, but we'll see. No, it actually makes it worse. That's interesting. Well, technically speaking, now it's the ship vibrating while the pilot ring remains nice and rock solid. This can't be right. There must be something screwy happening here because this is so weird. I mean, obviously a ship shouldn't be vibrating in that manner. It's not like I'm losing frames. It's just vibrating. It might be because I'm doing things in a physics update and then the frames end up screwing it up. Seems weird though. Let's go ahead and set this up to look at the cockpit rather than the ring and see whether or not this works. Well, it has a distinct problem of not actually looking in the right direction, which we'll go ahead and talk about in a minute. But first, let's go ahead and try and get this ship to fly. Okay, so right now we would be seeing the vibration and we're not. Okay, so so now the world is vibrating and we aren't. So there's definitely something going on here where the ship's acceleration is churning. It's vibrating somehow, and I don't know how. So because the pilot ring depends on the ship's velocity, when the ship's velocity vibrates, the pilot ring vibrates. However, even if we're not looking at the pilot ring, there will still be a vibration. We'll either see vibration in the ship if we're looking at the world, or in the world if we're looking at the ship. Classic frame of reference issue, I suppose. So the question is, why is there so much vibration in the ship? And I think the issue is when it reaches the target speed, it continually backs off and then accelerates again. And that is presumably the issue. And that's presumably what's going on. And in order to fix that, what we would do is we would try and peg it at the target velocity rather than allowing it to go over. That's here in fixed updates align. Here it is. And you see how we get the thrust quantity and the strafe quantity and all that stuff. When we actually try to determine the rigid body velocity, this is when it happens. Ship.rigidbody.velocity plus equals heading times thrust quantity. The thing is that when we get to go too fast, the heading will invert because the ship will want to decelerate. And we'll end up with something where we vibrate violently. And I'm presuming that's what's going on here. This if forward velocity percent is less than throttle is the reason that it used to work, but we've now changed how this system works. And I don't believe that this mechanic will work anymore. No. On the other hand, we're getting vibration before we've hit max speed. And we're not getting any let up in the vibration when we try and decelerate, which implies that there's something more fundamental going on here. God damn it. All right. So let's go ahead and do some debug logs. Debug.log heading plus comma plus thrust quantity. And let's see what sort of heading and thrust quantity we've got. So there we're getting some pretty serious vibration, and if we take a look at our logs, you can see that it is steadily decreasing. The velocity we're looking to reach is steadily decreasing, which makes sense because we're steadily accelerating towards our target velocity, and that's the delta. You can see that it's nice and clean. It just continually is decrementing like by 0.15 every frame, or every physics step. That's fine. Here you can see that we have a continuous stream of thrust from our engines. That's not changing at all. So the question is, why is it vibrating? Because these numbers are super clean. The only thing I can think of is, am I not cleaning the heading? I'm not cleaning the heading. That's the problem. Okay, so if we try to get this to work out, what we can do is right now we are doing this thing where we're dividing it by a huge amount. Let's go ahead and... These are all magic numbers. I haven't really got a good grasp on them, what I'm trying to do with them yet. But let's go ahead and see whether or not I can work this out. We should have roughly the same kind of situation. The reason I didn't do it like this before is because it produces a really snappy acceleration in certain situations. But we're still vibrating. See that? Okay, so if we take a look here, we take a debug.log ship.rigidbody.velocity. It may also be something about the rigid body's fundamental limitations. There's no real problem here. I don't see any like maximums or anything. So if we start to accelerate, I'm going to go ahead and try that one more time because I moved the mouse a little bit and it got my vectors a little bit off of true. So you can see that we're vibrating like hell. And if we take a look at what we're seeing here, 23.3, 23.2, 23.0, the velocity of the rigid body is simply accelerating in a linear fashion. There's no vibration here. So what's causing the vibration? Well, we're looking at the pilot ring, but if we stop looking at the pilot ring, either the ship or the world vibrates. Something is always going to be vibrating, which implies that there's something vibrating. Pink Hair's going to dinner. Can't guarantee I'll still be here when you get back. So So we're looking for the mysterious vibrating element. What's causing the vibration, and how do we stop it from vibrating? One issue is that it could theoretically be because it's in fixed update, but this is a physics thing, so it should be in fixed update. Well, I guess what we can do is put it into our update and just see whether that cleans it up. It doesn't seem like it should. I have had some problems with this kind of churn. Pinker says, put the camera look into late update. I'll check that in a second here. Well, that didn't help at all. So we're going to go ahead and put that back into the fixed update because that's where it belongs. And then we'll go into our camera and see whether or not that's happier in late update. I think it might already be in late update. Chase cam. No, it's just an update. Late update. Thank you. No, we're still getting vibration. What other values should we be examining to see whether or not the vibration is happening? Well, we can always look into everybody's favorite ship position. So, where is this log? There it is. We'll go ahead and add in the ship position verse ship.transform.position. Hope you couldn't hear me adjusting the mic there. So you can see that we're already getting vibration, and it's really quite bad. It looks like desync almost. But if we look at the actual values that we're seeing, we're not seeing that happening here. It's a very smooth acceleration with all of these coordinates being a linear increase. So we're just moving forward at the rate that it says we're moving forward, and there's no vibration of any kind anywhere. Let's add in the pilot rings location. Something's got to be vibrating. I'm pretty sure I'm not moving the world. Okay, so if we take a look here, the pilot ring is -49, -48, -48. So that's 0.5. That's 0.3. That's 0.3. That's 0.3. That's 0.4. That's not any change. That's 1, and there's not any change. Okay, so it's clearly the pilot ring that's doing this. That's interesting. There's some reason that the pilot ring is not properly updating. Maybe the pilot ring needs to be set up to move itself in at a different time. Put this in fixed update instead, just to see what happens. Dinner false alarm, Pinker says. Now you're making me sad. Huh. Yeah, you know what? That fixed it. Okay. So the issue here is that we were doing all of this velocity manipulation in fixed update. And then we were moving the ring in normal update. And I figured that would be fine because normal update happens before every frame. But apparently the syncing between fixed update and normal update meant that sometimes that physics didn't actually hit the pilot ring, even though it hit the ship. So it ended up making this situation where the pilot ring appeared to vibrate violently because every few frames it wouldn't get a physics update. And now that they're synced up, it should be fairly smooth, right? Yeah, I don't see any issues here. Yeah, this feels pretty good. Let's go ahead and write that to a GIF. All right. Do some more flying just to check it out. Yeah, that seems to have completely fixed it. Go us, I guess. Let's go ahead and write that as well. Yay! We're just taking a bunch of GIFs because I think people like GIFs, and why not, right? Only problem is the GIF library I'm using is just the first one I found, and it's not actually very good. So it outputs really, really tiny GIFs. I'm going to go ahead and increase the size of the GIFs. Not open. Because right now the width is 320, which is pretty small. What's the best width for a Twitter GIF? Pink Air says, very impressed by the progress. Thanks, I'm not. Twitter GIF ideal size. Maximum is 512, collapsed to 253 on desktop. Well, okay, let's try that 512 width and see how well that works. Wait, it's 1024 by 512 vertical. So that means that this would actually be quite small because it's width of 512, which is half of Twitter's maximum. That's fine. On the other hand, apparently the actual scale is like 1 by 2, so we'll go ahead and give ourselves a little bit of a little bit of a letterbox and play around with that. Oh, got the hiccups all of a sudden. Sorry about that. Pink Hair says that his experiments didn't work out nearly so well, and I have a lot to be proud of. Hey, Pink Hair, if you think I have a lot to be proud of, you didn't show up for the ones where I actually did the stuff that you're good at. You only show up for the ones where I do the stuff you're bad at. I spent a couple of weeks working on shaders with extremely mediocre progress, and you weren't there for those. But you did stop by to do the physics and camera stuff, which, as I understand it, I have a couple of advantages over you on that. That certainly writes a lot slower. That's fine, Pink Hair. I got through okay. I was doing a lot of surface shader stuff, and I got a couple of visitors that actually knew what they were doing, and they helped me out pretty strong. I got through it with their help. But it was funny. The effect that you're seeing on the flight, where I have these glowing hatch marks, that's a shader. The ship is also using a custom shader. I was planning to do greebling with a shader, but I couldn't get greebling to look decent when it was just a texture, so I applied some melting greebles, which you can see on the back of the ship there. If we zoom in on the ship, I've just gone inside the area, so it's a little hard to see. Let's go ahead and just... Come on, seriously? No, fine, we'll move the whole ship. These here are melting greebles, and what they are is they're meshes which then just get flattened onto the surface of the ship when you hit play. When you first start, they look more like that. See? And these kind of stick and peel greebles probably work fine for most people's needs. But I was really hoping to do algorithmic greebles. I just can't figure out a good way to do them. I think I'll probably revisit it and try again. But as you can see, I've also implemented the ship fading, the specialized color overrides and stuff like that. So hopefully we'll be back into feeling like a relatively decent ship at some point in the future. But I think I do need to go back in and do greebling details, even if it's not... even if it's not something big. I need to have one part of the ship have texture. And I think that might be a good thing to do now that I'm thinking about it, because it's on my mind that I haven't forgotten how to do this shit yet. If I put it off too much longer, I probably will. So we're going to go ahead and try and add that back in. The problem is that the custom texture I'm using for this is not suitable for my needs. So what we need to do is import the texture from the other project. Game object, component, assets. Import new asset. We'll drag this over here. And we're going to go over into the Galactic Line assets, resources. Nope. Textures. I'm not sure how to lot of textures. I just need the default crappy texture. Ah, here it is. Surface details dot boom. So there we've got our surface details dot boom, and this makes for a relatively decent just random surface detailing. We're going to want to duplicate this and create a normal map out of it, like so. And we're going to want to make that a smooth operator. We'll call this surface detail normals. And we'll want to go in and make that the texture for these instead, just because the Greeble map that we've got now is terrible. I do not have the ability to use a normal map here because I didn't program it. But you know what I am capable of doing is programming it. So let's go in and set that up. Ship Greebler. Pinkhair 3D says, that is really cool, and I really want to know how you did it because I've done some bad experiments along those lines myself. Are you talking about the glowing ball, or are you talking about the ship greebling? Or are you talking about the melting mesh? Sorry, I got too far ahead of where the comments were, and I don't actually know when you are commenting. So we're going to add in another map, main texture. We're going to call this main normal. The melting mesh. Okay, so that's actually a little bit complicated, but I can explain it. It's not too bad. First things first, you have to realize how this mesh is made. This mesh is a special mesh in that when I created it with a part of the mesh. I wanted to open the... There we are. I created it with a part of the mesh below the y-axis and a part of the mesh above the y-axis. You can see that green line there? So these points down here are all below the axis, and these points up here are all above the axis. So then what I do is, in the actual melting object, I go through and I get all of the verts, and then I sync all of the verts that are below the axis. I do a raycast for every single vert, and I do it downwards, and downwards according to the overall structure of the overall transform of the Unity object, not the mesh idea of downwards, but the Unity object ideal of downwards. And because of that, I just lower them down until they hit something, and then all of the things that are above, I just lower them down as much as whatever is nearest below them got lowered. So basically, I shrink wrap the bottom layer to the ship, and then I take the top layer and I move it down by however much the bottom layer got shrink wrapped. And it works pretty well. It's not really very complicated. If you need this code, I can send it to you. It's not difficult enough to worry too much about. Pinkhair says, did I ever send you the substance of that texture I did? I can't recall. I don't know. I don't know if I have any way to read it. I don't recall ever getting it, but if it came in a format that I couldn't read, I might have just been like, oh, whatever. So the ship Greebler gets a main normal map, so we're going to go ahead and put that in here. And now down here, we're getting this Greeble setup. He just ended up using the local height of each point. That's not a bad way to do it, I guess. I didn't want to do it that way, so I didn't. So I'm not sure exactly why you had trouble. Maybe it was a conversion between local and global that gotcha. There's lots of things that can go wrong. Another thing that often happens is if you are using the normal of the vert to do a shrink wrap, that's not going to work because you have to use the mesh object, the actual Unity object's downwards vector and not the vertex normal. So we've got a greeble, and we need to get our greeble going. Here is the fixed for greeble, and we're going to use the greeble Z to offset some stuff here. We can set the C.RGB up to use the greeble's situation here. So the greeble.z is how much we want to apply our greebling texture. But what we actually need to do here is it? No, it's not. I'm lying. This is all nonsense. The UV that we're using is actually how greebled we would like it to be, but then we have to get the fake UV. Here's our fake UV. So what we really want to do is get the amount of color in that fake UV and lerp between that and the amount of color that we have without that. Pink Air says, my issue came with recalculating normals and tangents to match the surface below. I was using it for conforming objects to a ground plane. So if you're trying to do tangents and stuff, things get more complicated. I'm not doing any of that. I'm just shrink wrapping straight down and just leaving it wherever it falls. So it's not nearly as complicated for me. So here is what we're going to be doing. Fixed for C equals color times in.color. We're going to be going ahead and making this color here into a lerp. So lerp color, comma, and then we need to get the color from our main texture. And then we need it to be the in.uv main text.y. And that'll give us as much of that color as our object wants. And then we multiply that by the color of the vertex, which will give us that nice tapering color that we get all over our ship. But we also need to do the same thing for our normal map. So here we can see O.normal, and then we'll go text 2D. Is it not text 2D if it's with normals? I don't know. It might be something besides text 2D. Text 2D if it is on a normal map. Don't know. We'll find out, I guess. All right, so you can see that this is extremely bright, and the reason for that is because we haven't assigned the UV values. Those are assigned at runtime. If we hit play, aha. So now you can see that what we've got is an extremely bright ship, but it tapers off to a darker shade back here. Now the question is, why is it extremely bright? That's a good question. Even the highlights are extremely bright, even though they're theoretically blue. It might be because the normal map, I didn't give it one. Let's go ahead and give it a normal map. Because if you don't give it a normal map, it may just be calculating, empty space as the normal map, which is obviously not ideal. Oh, still the same. So there's something going on here where it is showing up as a really, really bright and vibrant white. Now, why would that be? So this color is probably the issue. Let's go ahead and comment out a lot of this. We'll comment out the part where it calculates the normal, and we'll try and just figure out whether or not the normal. Okay, so it is the normal that's screwing it up. As you can see, this part works fine. So that means that I need something that's a little bit different for the normal here. Oh, I've been getting a comment from Pink Hair. The way that Twitch handles private comments is extremely weird. But we'll go ahead and pop that up in its own little frame off to the side. Yeah, I have a bizarre file at the thing you gave me, so we'll just go ahead and save that, and I'll look at it later. I don't think I can read bizarre files because I don't have every program that that exists. And Pink Hair's leaving for real this time, even though now is the only time when I actually need his advice, because I don't know how to apply a normal map. Probably something besides this. Let's just try Googling it. So we'll go shader, apply normal map. How to apply normal maps when creating textures and shaders in Maya. I don't want it in Maya. Unity. Adding normal mapping to my custom shader. Do do do. Do 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 do. This guy's just being an ass. So that's not going to help at all. Darn it! How do I get this to actually apply a normal map? Maybe I could look it up on ShaderToy, but if I tried to run ShaderToy while I'm also running OBS, we're going to have issues because ShaderToy uses a lot of the same pieces of the computer as OBS. So we'll leave that for later, I guess. Maybe I can get some of these to actually tell me just by the fact that it'll look differently. All right, so if we take a look here at transform text, that doesn't seem right. Using mesh normals. World normal, mesh normal, normal. Normal is a 3D vector with XYZ components. Yeah, I'm aware. Do I have to add it? Is it adding it rather than lerping it? I bet it's adding it. Let's go ahead and try it. O.normal plus equals lerp. Instead of O.normal here, we'll just go ahead. Can I just multiply it? Yeah, that looks more like it. Perfect. All right. Use your brain and stuff happens. So we still have a couple of things that don't really work out here. One of those things is that the sides are not getting their own texture elements, so they don't have the proper ribbing or anything. And another is that the overall visual isn't working out because the actual scaling involved isn't the greatest. So what we can do is we can take one of these elements here and change the scales so that it looks better. And you can see that you can do a lot with this, but basically the higher it is, the more dense all of these objects are going to be. So we'll just find something that looks decent for now. Y doesn't seem to have any opinion, and Z crushes it, as you can see here. So we'll go ahead and make it something like this. And then we're just going to want to copy those down into the other object so that it also has the same lineup. So the issue now is that we don't really have a proper fade off as I expected to. The problem is that Y of 0 is actually out here somewhere due to the way that the arms are deployed. And we got some vibrating. I think that that's just duplicate meshes or something. I think that's actually a duplicate mesh inside of Blender. I think I screwed up when I created that mesh inside Blender. Let's go ahead and fix it inside Blender. Here is the object in question. And as you can see, it has an XZ mirror. Hello? Come on. So if we were to move this and take a look at what exactly is being mirrored, if we unmirror the X, you can see that we still have elements, and that's the problem. So we'll just go in here and delete all of these elements to the side, like that. That's better. Save it. And then it'll stop vibrating. But we still have an issue where these are being applied a little bit wrong. And it's probably just because the Y value is a little bit forgiving, but I'm not 100% sure. It could be because the Y value is always 1. Why is that still there? Didn't I fix that? Well, we'll deal with it later. Clearly the Y value is pretty strong. If I were to move this forward... Oh no, the Y value would still be the same, wouldn't it? Let's go ahead and take these guys, duplicate them, and move them up here. Didn't work? Try that again. Okay, so if we look at the values up here, you can see that there's something a little bit strange going on, but I think that part of that is because these guys are in the way. No, that's interesting. Why is it gray on the left-hand side? That's weird. I did something in a shader and I screwed it up. No, it's still gray. Okay. If we rotate the ship, yeah, it's definitely gray. So there are two reasons it might be gray. One is that the coloring might be being applied, and another is that the there might be an error in how it's being calculated with the UVs. Let's go ahead and just double check the UV system before we do anything else here. So if we look up our mesh fader, and we look down at the UV map that we create, here it is. So we add it to the Y, this Greeble percent, and what we end up doing here is getting a value between -1 and 1, and there's the problem. It's not a value between 0 and 1, it's a value between -1 and 1. So we'll just drop that up here instead, and now it's a value between 0 and 1. That's more like what I had intended. You can see how there's no greebling of much import up here. And as we come back, it slowly gets stronger and stronger. So what we can do is we can do things like square it, but that still doesn't explain why this side of the ship is dark. It might be because my normal maps are not being correctly dealt with. Do I have to... Okay, so I'm clearly adding the normal map in terms of it being an addable thing, but there it is. That's the other problem. Same basic issue. Sorry, just give me a moment to fix this. Boom. Okay. So I'm clearly adding the normal, but I think what's going on is I'm adding the normal in local space, or I might be adding normal in the wrong space. That's all I can think of. I'm going to go ahead and comment that out for now because it's distracting. We'll come back to it later. What we're going to do with the mesh fader here is we're going to actually square the Greeble percent. And that way we'll get a sharper curve. Yeah, I'm definitely dealing with the normal mapping wrong. I'll have to look that up later. So without the normal mapping, this is how it currently looks. I think there's a... Yeah, that's better. To be honest, the greebling seems to be going in the wrong direction. You can see how it fades out towards the rear instead of getting heavier. So that's probably... Oh, of course, I see why that is. We'll just go ahead and make this a negative. Boom. All right, so we made it a negative, and it didn't help at all. Fascinating. So color fade is the graph that we're using, and it goes from 0 to 1. And let's just take a look here. Val.y, our val is equal to the magnitude of the vert. And then if the vert is lower, okay, so the bounds.x, okay, so that'll give us the correct axis. Yeah, that's all correct. And then the val will determine where we are relative to so all of this should work. Why is it insisting on giving me the front of the ship every single time? Look how it's always the front of the ship and never the rear. That's very strange. Did you notice how it's a different kind of value? So just take a look at this. This is the same ship, right? And when I look at it here, you can see how it's got these beams. Bum, 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 bum. But when I change the Greeble percentage to a negative Greeble percent... Oh, it's supposed to be a 1 minus Greeble percent, you idiot. Obviously. Okay, that should fix it. Yeah, that's better. That's what I wanted to see. And you can see how the greebling comes in, and then at the very back, it starts to hit nice and hard. The only problem we've got is that for some reason the greebling is substantially more aggressive on smaller objects, leading to these situations where we've got this lightweight but very dense greebling up in the front, and in the back we've got heavy greebling, but there's not like a lot of it. It's pretty loosely packed. That's kind of interesting. I don't know precisely why that is. But all told, this is basically what I was hoping to get. It's just a matter of tweaking it until it makes sense. And one thing you'll notice is that our vertex color stops being applied as the greebling gets stronger. And that's incorrect. We want the vertex color to continue to matter. Here's where we multiply it by the vertex color, I thought. The underscore color is the color of the ship in general, whereas in.color should be the color of the vert. Either way, we are clearly multiplying the color by the color of the vert. So why is it fading away? Maybe it's because it's fading towards a darker color? That's weird. Oh, I'm an idiot. I've got it precisely backwards. This is the color that is the color of the material. This is the color that's the color of the vert. The vert color is... Okay, so we need both of these outside. But obviously that means that we've got to lerp against something, and we're going to lerp against the ungreebled color. I think we could also just... Because the ungreebled color should be white, right? Yeah, that's more like what I want to see. All right. So that's a much more aggressive shade. Now, if we go in here, we can try and adjust this so that it is a little bit more acceptable in the back. Yeah, I guess it's... Look at how it scales. You see that? It's so strange. It's like... Whoop, whoop, it stretches at the back there. That's quite odd. Not really sure why that is. Let's take a look here. Oh, of course, because we're the UV map isn't being affected. It's only the density that's being affected. The UV map is the absolute value of the X and the Y position modified by the ship scale. So that shouldn't be stretching because there's no stretching involved. That should be pretty linear, but it's clearly not. That's very strange. But since those are the local position, that means that the ship doesn't have like a problem with vibrating objects. As we move through space, it'll remain greebled in precisely the same way. But it does mean that the components that can move will end up moving, as we'll see here. So we'll end up with some bad distortion on the objects that are skinned mesh renderers. And you can see that happening right now, I think. Yeah. So that's why normally when you assign a UV texture, you don't use the world coordinates or the local coordinates, because if you do, you end up with some trouble. Now, there are ways to assign multiple UV maps, so I could use one UV map for greebling and another UV map for arbitrary texturing. But if I'm going to use arbitrary texturing, I mean, there's not really any reason to not use built-in UV maps that I make in Blender. All right, well, let's adjust this one more time, and then I'll take some screenshots. For some reason, I'm hungry, like real hungry. I'll have to fix that. There's a little too much repetition right now, so we're going to move this until there is a little bit less. We'll go ahead and make it there. That's a little bit good. And then we'll copy this down into the other material so that we have the same values on both. I think that this x-axis is just not quite right. What do I want to look like? It's a little bit too delicate because dragging this is so aggressive. See how aggressive that is? I gotta decide what I want to see on the sides too. Something like that. That's pretty duplicate-y. How about if I were to bring it out like this? That makes the back look kind of bad, but I can adjust the z-axis again. There we are. Something like that. Let's go ahead and try it. I might use the real UV coordinate system and then use the secondary UV coordinate system to determine greebling. I was going to avoid UV stuff, but I don't know if I can greeble convincingly without it. I'll have to think about it. All right, we're going to take some last-minute GIFs, and then I will see you all in the future. So if you've got any questions, now is the time. I can't believe that was only an hour and a half. Gosh, that felt like 3 hours. I guess not, though. All right, one GIF down. Let's do one more GIF. Maybe a better robot arm GIF than the one I released the other day. Oh, I've got frigging duplicates up front just hanging around, idiot. Let's try that again. That didn't come out very well. This is the fun part, right? Where you desperately try to make your own project look at least vaguely interesting. Oh, that didn't work. I really bumped it. Trying to get in and then stop is still a little rough. I guess I could get in and then just ram the wall. Not quite as elegant, though. I'd like a little bit more elegance. There we are. That should do. All right. Well, we had a very productive day. And I think that that is good enough for me today. And I'm going to go and eat as many things as I can find in my house. Which sounds like a lot, but I happen to know for a fact that I need to go shopping, and all I've got in my house is leftover casserole. There we are. All right. So, thank you for being here, and I'll see you on Wednesday if that's what you'd like. Bye.